Welcome to University Physics 1 for summer of 2021. I'm Raymond Binge. I'll be teaching the class here, and basic idea of how this works is I'm going to be recording lectures and posting them online. I'm just going to post them on a YouTube channel, and so the lectures will be available to you however you want to watch YouTube. I have some students who watch them on their phone, on the computer, on their TVs. You can stream it to a variety of different things and watch it. One advantage I've had students tell me about doing it this way rather than doing it live or even in person is that if they miss something, they can just rewind it and go back over it again. Being on a YouTube thing, depending on how you play it, you can actually speed it up or slow it down, even if you want. Pause it to take notes. I would encourage you, don't just watch them, but take notes as if you were in class. So the lectures, I explain some of the topics, and I go over problems, example problems. Those example problems are important because the tests that are going to be solving problems, and so you want to be able to solve problems kind of like I'm doing example problems. Well, obviously, I ask you test problems. I solve problems. So the problems I solve are going to be the same sort of things I come up with to ask questions about on tests. The tests really, everybody focuses on tests, but the tests are really only about half the class grade. I've posted a copy of the syllabus for you, so you can look at that and see what's going on. The lab is about a third of the course grade. You'll be doing a variety of labs each week, so you're going to have a practice doing lab work, and most of the time we'll be doing a couple of labs per week. Some weeks just one lab, and so that's going to be sort of the format here. And then homework. Students always hate doing homework. Well, the homework, obviously we're doing this kind of at home, but the homework is your practice problems. So the more problems you do, the better you are at doing problems. So I can sit and just open the book or whatever and do a problem, not because, I'm super smart and, understand the thing just instantly, but I've been solving physics problems for decades, and so therefore, when I get ready to solve problems, it's like I look at a problem and I say, oh, at some point I have solved a problem kind of like this, and so I know how to approach the problem. The more problems you do, the better you are at solving problems. I spot and grade the homework, so I don't have time to grade each and every problem you submit. So you might have a homework set, and I might, only randomly pick out 1/5 or 1/6 of the problems and grade those. The homework is only about 5% of the course grade, so it's not a huge amount. But it is enough to half a letter grade, so you don't want to not do the homework. But you're better off turning in half completed homework than no homework at all. At least practice, do the more difficult problems, do the easy problems, do at least a problem from each section, whatever is your strategy. The more problems you do, the better. I have had students who I think had no life, and they did not just the ones I assigned, but every problem in the book, and then they went down to half-price books. They got another physics book, and they did all the problems in those books. Students that do that typically get in the upper 90s on every test. So obviously doing all this extra work does help when you're trying to learn how to solve problems. And so doing homework really does help. The labs are going to be things that you do on your own. Some of them are going to be pencil, paper, calculator type things. Some of them you've got to graph. Some of them you've got to use computer simulations to do them. And so those will be available for you. I'll be posting them online. The other thing is I want you to be engaged in the class. So for each topic that we cover, each chapter, there's going to be an online discussion board where you get onto the discussion board and you ask a relevant question. Don't just say, what's on page like such and such of the book. Say, hey, I was reading and I wanted to know, does this apply to such and such situation? Or, hey, the professor said something about this in the lectures. I was reading something like, that, how does this relate and so forth. I want you to answer someone else's question. So that means that you need to, read and listen what other people ask and say, hey, I have a question here. Or I saw someone else had this question, and here's the answer. To answer the question, you might have to actually look up something. You might have to calculate something. You might have to actually apply things. So I want you to actually answer questions that other people have asked, okay? And then I want you to also just kind of make a generic comment or reply to someone else's comment about what you think is interesting in here. And that kind of helps me figure out, where are we and so forth. So how are we all learning and how well are we all learning here? And what do you actually find most useful in here? When I've been asking students here since we've been online to tell me what they find most interesting and most useful. And so sometimes I find out what they found most useful was not really what I thought they would find most useful. And so I'm going to stress some of that stuff. So anyway, that's kind of the basic idea here. The syllabus gives you the basic sort of things, what's due, when it's due, and how it's due, basic sort of table here of what labs we're doing and when, and I'll be posting these things on Blackboard. You'll be turning them in on Blackboard, and so this will all be out there for you. I'm also going to have a couple of live question and answer sessions each week. And so that's going to be something that you can get on, ask questions directly. So this will be like office hours. It'll be also like review sessions. It will be like, hey, I didn't quite understand something, and this will give you a chance to understand, ask a question and get clarification and understanding. Again, we've been doing this online stuff for a year now, and what I found is that while these things are optional, students who actually come to the Q&A sessions typically do better on tests than those who don't. It's not universally said, that's not universally true, but that is an observation that I have made. And so think about it. The final thing here is that there's going to be a handful of little short papers, like 1 to 2 page papers that are due about some current topic in physics. And say, well, what do you mean? Well, what I want you to do is just read the news. And so you might be reading the news and you might see that there was a car crash, and that catches your attention. Hey, well, there's this terrible car crash. Then what I want you to do is, in about a paragraph, just a few sentences, summarize, hey, there was this terrible accident on highway whatever, here, and 2 cars hit head on and people were killed. And then the next paragraph, I want you to explain the physics of that car crash. Not in great detail, but in about a paragraph here, several sentences say, well, in chapter 9 of the textbook, we cover collisions. And in a collision, we realize that what makes this collision bad are 2 things. First of all, the speed of the vehicles and the relative speed. Well, these cars weren't just moving, but they were going head on. So the relative speed was actually greater than if one had been sitting still and then a collision. And so that doubled the impact velocity relative, which drastically increased the effect of the collision. And so we have conservation of momentum involved in here. They came together, head on. They crashed. We have conservation of energy. That energy had to be conserved. Well, it ended up being transferred from the vehicles to the occupants of the vehicles, and that's why these people were killed. And so explain that, and then give a bibliographic citation. It's a college level paper, so you want to explain what you did. And so that's all in here. And again, that's not a huge percent of the course grade, but it's about half a letter grade, doing that. So the idea of that is to think about physics as not just solving problems, but applications in real life. Doesn't have to be a car crash. You could be reading a story about baseball. Chapter 4 is projectile motion, baseball. Okay, you throw the ball, you hit the ball, you catch the ball. That's all chapter 4 topics here that we're going to be covering. And so you'd explain how that relates. And so, physics is everywhere. So the idea of these little short papers is not to do a research level science stuff, but just read the news and realize, hey, physics is applicable in everyday life. And so that's what's going on here is physics. And so that's kind of what I would want you to be doing in those papers. Okay, so that kind of gives an introduction as to what the course is about. Chapter 1 is going to be basically just introductory stuff. Now, what I'm going to be doing here in the live sessions is I will record them. Even if you don't attend the live Q&A sessions, I really think you ought to show up to find out what we're talking about, because I will kind of go over basic ideas of what's coming this week and how it relates to other stuff. So that's something that you really want to be actually doing, is showing up and looking at those things. So at any rate, I'll be sending out more information here online beyond that. But this is basically how the course is oriented. Welcome to physics. Hope we have fun doing this. Hope we learn something. My main goal is to prepare you for later classes. Very few people actually take University Physics 1 as an elective because they have nothing else to fit in their schedule, and they say, what do I take, a PE class or physics? No, it's you take the class because most of y'all are going into science or engineering type fields, including computer science in there as well. But you're going into science or engineering fields, and you need this class for upper level classes. What you learn in Physics 1, you're going to be using in Physics 2. You're going to be using Physics 1 and Physics 2 stuff in some of your upper division classes. That's why we're doing this. That's what I'm looking at, and long term, I'm trying to prepare you to do well in your later classes. And so that is my main goal here, is to make sure that you learn what you need for later classes. People that skimp by in Physics 1 typically don't make it through a science or engineering degree because they don't know what they need to know later. I want you to learn so that later on you're going to do well. So that's my main goal. My highest praise is not from students who say, hey, this was an easy class, but from students who, like 2 or 3 years later down the road, email me and say, I'm so glad that I had such a good physics class, for Physics 1 or Physics 2, because that has helped me so much, and it has been so useful in getting through these later classes, and so that's what matters a lot to me, is making sure that you do well when you go on to later classes and you actually get a degree in science and engineering. So with that, that's my introduction here. I'll pause this and then we'll go on into the regular lectures.